Hello again, and welcome back to a Monopoly tutorial. This is about the bulk pricing function. I'm not having a good go of this tonight, so I think I'm going to hang up my tablet after this and do some more when I'm fresh in the morning. So Patricia is a collector of turnip patch tots. Her demand function is QD is 1000 minus 20p. Suppose she is able to buy them at her favorite retailer Malwart for $20 each. Now suppose that her good friend, the owner of Malwart, Wham Sultan, offers to give her a bulk discount. If she purchases over 750 turnip patch tots, she can have them for $10 each. Draw a graph of Patricia's demand function and the bulk pricing function. Will she take advantage of Wham's offer? And then a follow-up question is, how should Wham price his bulk discount to extract all of Patricia's consumer surplus? And I should add on to that if his marginal costs are, let's say, $2. Okay, so basically, in order to do a optimal bulk pricing discount, you need a marginal cost. So, if you didn't know that, then good luck. If you did know that, then now you have all the information you need to solve the problem. So have at it. Okay, so here we are with now the answer. Okay, I'm going to just go right ahead and put this into the market demand as we're used to working with it for monopolies. Okay, so that's sort of what we're working with. So the price high is 20, price low is 10. Okay, so this is sort of an easy introduction question to get you into how to think about bulk pricing discounts. Her demand is, of course, a negatively sloping demand function. The intercept here is 50. His pricing scheme is that for $20 she can buy up to 750. You don't actually know that this line crosses twice unless you made up the question like I did, and then you would know that. There's of course ways to check it that you will see when we get into solving the problem. Okay, so that's the basics of what our demand looks like, right? So for the first 750 units, right, she can buy at $20. Every unit after that costs her only $10. Okay, so since we know that his marginal cost is 2, we know that he's still ripping her off, but hey, she's a crazy lady who collects millions of dolls, so maybe that's what you get. So the first thing we want to think about is, well, what's the point of bulk pricing? What do you get out of bulk pricing? How does bulk pricing work? Well, basically, if you're Patricia, you know that you enjoy positive consumer surplus all over the place here in what I'm calling area A. Okay? You know that once you pass point D, then you're starting to pay more than you value these dollars at. So for area B here, which enjoys negative consumer surplus, which is why I'm putting in all these little negative signs. But you see that once you pass point E and start getting the bulk discount, then we get these little positive areas here in area C until at point F you value the last doll that you bought at exactly $10 and you stop buying them. Okay? So if I'm Patricia, I'm going to buy up to point D automatically without even the bulk pricing offer. I don't care about the bulk pricing offer. I know that I value X number of dolls more than $20. So let's figure out what that number is, right? Just like an ordinary demand function at a price of 20. And I'm not even going to bother to plug in numbers anymore. You guys can work a calculator. QD is going to be 600. So that's this number right here is 600. Okay. I know then that if I want to enjoy this consumer surplus, this positive area here, I have to endure this negative area here. So I think that I would do that if the pros outweighed the cons. Makes sense? So if C is greater than B, and because we're economists, we always need a weak inequality to make the micro people happy, which I guess you guys are micro people this semester. Consume at F if B is strictly greater than C, consume at D. You never want to consume at E because you get all of this negative consumer surplus area without ever reaping the benefit of the positive consumer area, and also whatever imaginary price this is not a real price that you could ever pay this guy for a doll. It's just a price that we're going to use to calculate the area of these consumer surpluses. Okay, so area A I get whether I consume at F or whether I consume at D. So all we're worried about is the area of B and the area of C. Okay, so let's start start with the good witch and think about area C. Okay, I know that this quantity here is 750. I can really easily figure out this quantity here, right? QD of 10 is simply 800. Okay, so I can bring this line down if I don't highlight everything with my pen. And this point here is 800. Okay, so I'm starting to get the makings of a triangle, right? 1/2 base times height. So I have the base, it's 800 minus 750. It's 50. Now the height, right? I know this low price is $10. So the price, or the height, is going to be something times $10, or sorry, not times $10, but minus $10. Okay, and what that is I can use the opposite, do the opposite here, and plug in 750 into my quantity and get what price that is. Okay, so if I do that, I get that that price is 12.5. So the difference there is 2.5. Okay, so then the area of the triangle must be 2.5 times 25, which is 50 divided by 2. So area C is 62.5. Okay, now let's think about area D. Okay, well I already know that the price, the high price is $20, that this price where it crosses is 12.50. So I know that height is 20 minus 12.5 over 2, and then the base, sorry, I just pre-divided by 2, I shouldn't have done that, I'm going to take that out. And the base is this 750 minus 600. Okay, so that makes area, well, it makes it 75 times 7.5, makes it 562.5. Okay, so clearly my drawing is A, not to scale, and B, it clearly shows that area B is larger than area C, and that she won't take him up on the offer. Okay, so now I asked you to figure out what he should do to get all of the consumer surplus out of this market that includes his friend Patricia. So I'm going to show you a couple ways to do that. I'm going to show you the quote-unquote easy way first, then we will do the quote-unquote hard way. Okay, so I already have that P equals 50 minus Q over 20. Okay, so what I want to do is come up with a bulk pricing scheme for this guy to tell him how to really really screw off his friend to the or screw over his friend to the best of his ability. Um, so to start with, any consumer surplus maximizing exercise, there can't be any positive consumer surplus. So the question of, can I start price below the maximum willingness to pay, right? Well, no matter what, there's going to be positive consumer surplus here. You can't get that if you start below it. So we're always going to start at or above um, the maximum willingness to pay, which in this case, if Q is 0, P is 50, we're going to start it right there. Okay? So this isn't a downward sloping line. This is a perfectly horizontal line, as you can see that I've drawn it clearly there. The next thing I can do, or next thing I want to do, is to move this down and have the bulk pricing scheme, but I want my low price to be my marginal cost. Okay? So if I price above marginal cost, right, if I say I price here, then I really could still be getting if I priced at marginal cost, right, the consumer would buy more of the items, right? So I'm making this triangle smaller, which is what I'm eventually going to want to equate to this triangle. And I really want this triangle to be as big as possible, because this is the area of my producer surplus here, right? Above marginal cost, but below price. Okay? So I'm going to erase all these things here. And I need some Q star here where I offer my discount. Okay, we've already told you that this is 960. Okay, and that's all we really know right now, because we haven't decided where this Q star is or what P corresponds to that. I can tell you that I'm going to label this as P of Q star. Okay, so now we just have to set up the equation that makes triangle, I guess this formerly was triangle B equal to triangle C, right? So my optimality is that I want area B equal to area C. Okay, and the area A from before, which I'm just going to go back to, can't exist, right? If area A exists, you haven't maximized your producer surplus. Okay, so well, area B, just like before, is 50 minus P of Q star. This is going to be important. It's the absolute value of 50 minus P of Q star. Okay, and that's multiplied by Q star, right? Base 50 minus P of Q star times height Q star, all divided by 2, because it's a triangle, and that equals, right, the area of C, which is 960 minus Q star times, and then the price difference, right, is P of Q star, okay, minus 2. Okay, so I know that P of Q star is going to be, the absolute value thing is not as important there, because I know P of Q star is greater than 2. The absolute value thing is going to be important because I'm going to cancel something out. And if you don't have an absolute value sign, then you wind up with a really weird, bad answer. Okay, so to start off with, this side is also divided by 2, but now I'm just going to multiply both sides by 2, so I'm going to get rid of those, and I'll get rid of those. Okay, so Q star being a positive number, I can multiply it into this absolute value sign with no problem. Okay, and I'm going to expand this P of Q star. So P of Q star is just the regular P function with Q star plugged in. So it's 50 minus Q star over 20 instead of just Q over 20. Seems trivial, but it is what it is. Okay, and you'll see that when I multiply the Q star through there again, I get this minus 50q again, right? So these can just cancel out, right? And I'm left with just this positive q star over 2, or sorry, q star squared over 20. So I'm going to put those back in because I want you to see what's going on. Okay. And that still has to equal. And now I'm going to expand this out. Okay, so I've got p of q star, which is 50, minus q star over 20 minus 2, so that's 48 minus q star over 20. So it's 48, like I said, minus q star over 20. Okay, just going to multiply these together to make it sort of easy. I'm going to get these q stars to also cancel out. Okay, so I'm going to cancel out from this line. I'm canceling out the 50 q star. So this is just q star squared divided by 20 equals 960 times 48, which I used to know. And I don't want natural log of 960 times 48. I want this to be 46,080. Okay, and then the minus q star times 48 is minus 48 q star. And 960 divided by 20 is also 48, because 96 divided by 2 is 48. And so it's again minus 48 q star. And then again we have a plus q star squared over 20. Okay, so these q star squared over 20s here are going to cancel out. So we'll have that 0 equals 46080 minus 96 q star. So 96 q star equals 46,080, and then q star equals 480. Now, if you're wondering how I did that division in my head, it's because I know a little trick about demand functions that you don't and probably shouldn't, because it will get you the wrong answer a lot of the time. So 480 is my q star. Okay, and then that's all I need, right? So I'm going to price first 480 units at $50, right? Her maximum willingness to pay. I'm going to price additional units are $2. And it just occurred to me that I might have said 5. No, I did not. Okay. I was thinking 5, but then I said 2. And I'm glad I was doing that. Okay. So that's our bulk pricing form in this very specific numerical solution case that I've just given you, where I pick an arbitrary price. I picked $50 because it's the maximum willingness to pay, and it turns out it's the easiest one to do. Now I'm going to show you a general solution, and we're going to check this 480 units at $50 P high as our sort of benchmark for whether or not this worked. Okay, so now in this market, in this bulk pricing scheme, I'm not going to restrict us to starting at the maximum willingness to pay, because in reality I can start way the heck up here, and as long as this area B equals this area C, even though they're not drawn to look like it, I will still get the maximum amount of consumer surplus. It's just not going to be the same Q star or pH. Okay, so P high is above 50, which is just my arbitrary notation for what the starting price is in the bulk pricing scheme. And Q star is going to be a function of what I choose P high to be, and that's what I'm solving for in this general case. P low is still marginal cost, and for reasons that I sort of briefly enumerated before, that has to be the case if you're going to maximize your producer surplus. So now I want to think of the same kind of thing, right? So area C is still going to be described by, right, because this is still 960. We're still working with the same example. So area C is still 960 minus Q star, right, times P of Q star minus 2, all divided by 2. Okay, but now area B has taken on a slightly different form. So area B has the same component that it did before. Right, so B is divided into B sub A and B sub B, because I'm not very creative. So B sub A, we'll do that first, right? That's just the difference in these two, in the two prices, right? The high price and the maximum willingness to pay. Okay. And as you can see from the graph, times Q star, which is why I like graphing, because it really kind of shows you things pretty conceptually, right? So I get the area above the maximum willingness to pay for the number of units that the person buys. Okay, then I also get the triangle B sub B, which is the same thing, 50 minus P of Q star times Q star divided by 2. Okay, and so area B then is just B sub A plus B sub B. Okay, and area B still equals area C. Operationally, this is the same problem we just did. So 960 minus Q star. I'm going to go ahead and multiply this out again, right? We had all these answers already. Or we had this multiplied out already. It was 46,080 minus... Okay. Sorry, minus Q star. Squared over 20. That's the problem. See, even when I try to skip steps, I do things bad. So, lesson, don't skip steps. Because this is a positive and there's also minus 96 Q star. Okay, so I'm sorry for that. That was kind of silly of me to skip steps when I really shouldn't have. And that has to equal, and since I've implicitly multiplied this, or this needs to be divided by 2, and I need area A plus area B, so that's just PH minus 50 times Q star plus the same thing, so 50 minus 50 plus Q star squared over 20 divided by 2, right? So these 50s are going to cancel out, and some of you may have noticed that I didn't write times Q star. Technically, I should have. I'm going to go ahead and multiply everything by 2, because I don't like denominators. They make me angry. And I multiplied through by 2, so this is now 100 Q star. Okay. And I still have this plus Q star squared over 20, but I don't have it for long because it's on both sides of the equation. So this just becomes 46080 minus 96 Q star equals 2 Q star pH minus 100 Q star. Okay, so again, just collecting like terms. 46080 plus 4 Q star equals 2 Q star pH. So I kind of want to solve for Q star or pH, one of the two, so that I either know what to set my discount quantity. So if I pick a discount quantity, I know what price I should charge, or if I pick a price, I know what discount quantity to do. So, I mean, probably easier for me at this point just to solve for pH. Either way is probably fine. But then, of course, pH is, what's half of this? 23040 plus 2, and this is divided by Q star. Okay, so that's my answer to this question. So now I guess my check is, if I put in my equation from before, do I get the right thing? So I wanted my price high to be 50 and my Q star to be 480. So I'm just going to check this just for my sake because I have been having a kind of rough night. 23040 divided by 50. Nope, not 50. 480. Is 48 plus 2 equals 50. So this is the generic formula for the explicit solution that we had before. Okay, so that's how to do this kind of problem. And again, I'm sorry, I'm going to stop recording these tonight and come back at it when I'm fresh. So thank you for bearing with me on this video.